Now we want to talk about finding an inverse function. Well, consider the function g of x equals 6 minus 4x. First of all, think about what type of function this is. Of course, we know this is linear because it's to the first degree. What are the domain and range of g? Well, since g is a linear function, its domain and range will be all real numbers. What is the inverse of g? Well, remember to find the inverse, the first thing we do is we switch the x and the y, as you can see we've done here, x, y. We'll take away the 6 because now we're trying to solve this equation for y. We'll then divide everything by -4. And we get the inverse is the opposite of x plus 6 over 4. Kind of taking the negative off the bottom and distributing to everything at the top. It's kind of like multiplying both top and bottom by -1 right here. Is the inverse a function? Well, notice that the inverse is also back to being linear because it's to the first power, so therefore, yes, it is a function. And if we looked at these two on Desmos, my favorite website for graphing, by the way, desmos.com. Taking a minute to load here. So you can see the red function is 6 minus 4x. Linear function, as you can see, going through the y-intercept at 6 and a slope of 4. So down 4 and over 1. And again, notice with the way this is zoomed in that we're seeing 2 at a time here. The green is the inverse, -x plus 6 divided by 4. So again, it's basically going through the y-axis at somewhere around, 1.5. And then it's coming down 1 and over 4. Now, I went ahead and threw in the line, again, y equals x. And we'll throw this line, we'll make it a different color here. Again, on Desmos, when you want to change the color, just click and hold. I can make that be purple now. And again, notice and imagine if we picked up this graph and we flipped it and folded it across the line where y equals x, this purple line right here. If that line were to be our crease mark, the red and the green lines would fall on top of each other, because a function and its inverse are always symmetrical with respect to the line y equals x. Let's go back to our notes. One-to-one functions. Kind of a definition that you need to know. We know that for any function, each x value in the domain corresponds to exactly one y value in the range. Let me get my face out of here. For a one-to-one function, it's also true that each y value in the range corresponds to exactly one x value in the domain. In other words, a one-to-one function f has an inverse that is also a function. We can use the composition of two functions to verify if the two functions are inverses of each other, such as this. If f and f inverse are inverse functions, then the composition of f and its inverse equals the composition of the inverse with f, and they both equal x. This is the one time that composition of functions must be commutative. That is, that the composition of the function with its inverse must equal the composition of the inverse with its function, and they both must equal x. For x in the domains of f and f inverse, respectively. This is so. If you're dealing with something and you don't have values in the domain, then it's not going to work. Such as in these next examples. This says that the composition of a function and its inverse is essentially the identity function y equals x. Take a look at this. Got a little out of order. G of x equals 4 divided by x plus 2. This is a rational function. We're going to talk about these in Chapter 8. What is the G inverse? So again, to find the inverse, we switch the x and the y. I'm going to go ahead and put x over 1 to make it a rational. We can then cross multiply. X times y over 2 equals 1 times 4. Because again, our goal is to solve for y. From here then, since they're multiplying by x, we're going to divide both sides by x and get y plus 2 equals 4x. We can then divide, we get y equals 4 divided by x minus 2. Well, if we think back to this, g of g inverse. What you need to understand is that a function undoes its inverse. Well, and this goes back to the functions that we just had. Since 0 is not in the domain of g inverse, this function does not exist. Let me go back and show you on slide 12. Keep this in mind. Here's the inverse. Well, the inverse of this function is all real or the domain of this inverse is all real numbers such that x can't be 0 because you have a denominator. So we can't let x be 0. The domain of the original, again, the denominator can't be 0, so what plus 2 would be 0? Negative 2. So now as we go forward, keep these two functions in mind. So g of the inverse of g of 0, since 0 is not in the domain of g, this doesn't exist. What about g of 4? Well, g of 4 does exist, so it's 4. Basically, this undoes the function. The inverse undoes the function, and the function undoes the inverse. G of negative 2, well, remember, function g, x can't be negative 2, so since negative 2 is not in the domain of g, this does not exist. And that concludes this part of the lesson.